Hi everyone, Chris Tisdell here again. Thanks for tuning in. In this presentation, I'm going to continue my series of videos on matrices. Now, we've been looking at the connections between matrices and linear systems. And in this presentation, we're going to look at how to reduce a matrix to a reduced row echelon form and then link it back with the solutions to a linear system. So let me share my screen with you and we can get down to business. Okay, here is an example that we're going to look at. So we've got a linear system of simultaneous equations, and we want to reduce the augmented matrix for this system and then to a reduced row echelon form and then solve the system of equations. Now, we have already looked at this in a previous video. Okay, now with this one, all we did was we reduced it to a row echelon. Well, it was actually already in a row echelon form. Okay, and we got some solutions for it. Now, let's see how this compares with that solution method. All right. Now, just to refresh your memory, a reduced row echelon form is a special kind of row echelon form where every leading entry is 1 and every leading entry is the only non-zero entry in its column. All right. What you do is you start with a row echelon form and then you work on the lowest row, get the leading entry to a 1 and then add that row to higher rows and you just keep on going. All right, so how does it work for an example like this? Okay, well, let's write this as an augmented matrix. It's already in a row echelon form. And we're going to see if we can put it in a reduced row echelon form. Okay, so how do we do it? Well, first of all, let's work on the bottom row. Okay, now the first non-zero entry in that row is a 1, so we don't need to do anything to it. Okay, what about the next row? Okay, well that's not a 1, but we'll get to that in a minute. Okay, what we're going to do here is get all of these 2 entries to a 0. Okay, so to get that entry to a 0 would be row 2 equals row 2 minus row 3, and to get that to a 0 would be row 1 equals row 1 minus row 3. So let's write those in. Okay, it's important that you record your row operations because it's easy to forget or make a mistake. And if you've ever been to my classes, you'll know that I make mistakes all the time. All right, so that's going to be 1. That's going to be -1. That's going to stay at 2. That's going to go to 0. All right, so that's going to stay at 2. Oh, sorry, that should be a 1 there, shouldn't it? There you go. You see, I've almost missed that. That will be a 0. Right, row 2 equals row 2 minus row 3. So that's going to be 0, 0, 2, 0, 3, and 2. And row 3 doesn't change. Okay, so now what? Okay, well, let's look at this leading entry now. Okay, now I'm going to, I do want to make that a 1, okay? But before I do that, what I'm actually going to do is I'm going to take away row 2 from row 1. Okay, normally you'd make that a 1, but that is a multiple of that. And I can just avoid fractions for that little bit if I do it that way. Okay, so I'm going to just do this operation. Now normally you would make that a 1, and then but you get 3 on 2 there. So I'm just going to do that. Okay, so it's going to be 1, -1, 0, 0. Okay, so 2 minus 3 will be -1, and then we'll get a -2 there, and nothing else will change. Okay, so now let's get onto this and make this leading entry for row 2 a 1. I can do that by multiplying by a half. All right, and then it looks like I'm going to have a reduced row echelon form. Okay, 3 on 2. Can't avoid that fraction, unfortunately. Usually we try to avoid fractions. And I get that. Okay, now the question is this in a reduced row echelon form? Well, every leading entry of each column is 1. So that's the first thing. And then every column that contains a leading entry, every leading column, has 1s and all 0s. Okay, and this is the only non-zero entry. This is the only non-zero entry. This is the only non-zero entry. So it is in reduced row echelon form. Brilliant. Okay, it's in reduced row echelon form. Now the second part of the question says solve the system of equations. Okay, let's do that. Okay, you can see here, this is a leading column, right? It contains the leading entry of some row. This is a leading column, and this is a leading column because it contains that and that. Now this column is not leading, and this column is not leading, okay? All right, now this column is associated with the coefficients of x2, and this column is associated with the coefficients of x5. So we're going to introduce some parameters here, and then we'll be able to get our solve our system, and we'll compare it back with what we've done. Okay, so I'm going to say let x2 equal lambda 1 and x5 equal lambda 2. Now, what does this row say? This row says x1 x4 equals 1. Okay, from row 3. Okay, so what we're going to do, we're going to use each row and use these parameters and this value to get x1 and x3. All right, so row 3, sorry, row 2, what have we got there? It says 1x3 plus 3 on 2 x5 equals 1. So if I rearrange that, make x3 the subject and plug in x2 for x5, lambda 2 for x5, I get that. All right, and lastly, row 1 says x1 minus x2 minus x5 equals -2. So from row 1, I get x1 minus x2 minus x5 equals -2. So if I rearrange that, make x1 the subject, and I know x2 and x5 are in terms of lambda 1 and lambda 2, minus 2. Okay, so let's highlight that. All right, so I've highlighted all of those things. Now, we've solved it. How does that compare with working with just a row echelon form? Okay, we did that in another example. Let me show you. Where is it? Just Just hang on a sec. Aha, here it is. Okay, so here we just did the row echelon form and introduced the variables and got that. We had to do a little bit more work to get these things though. Okay, so with this one there was a lot less work to do to get the solution set. Okay, so that's one of the advantages of working with a reduced row echelon form. You can either read off the answer, or it's very easy to actually get the answer when there's more than one solution. Okay. Anyway, hope you enjoyed this video. Hope you found it useful. If you have any comments, any questions, I always love to hear them. You can put them in the comment section. Thanks for watching. See you later. Hope you can join me again. Bye.